situation, we are always sure that the boundary is a kind of enclosed and consists of consecutive line segment, consecutive edges. But in some other cases, the mesh might not be that simple. For example, you have another piece of membrane branching out from here. Then the edge, you have the T-joint. Okay, in that case, it no longer works using this constraint by constraining consecutive edge with this constraint. Okay, in that case, you really need to find out what edges share at least one base point with the other edge. Okay. How about maybe we try to make it a cluster first, because I think this is very important. I would suggest that you make sure that you are very good in this clustering thing, so that you always know how to make your program clear and clean. Okay, otherwise you will be stuck somewhere. Okay, every time you start to write a program, and until it's getting more and more complicated, then you start to get lost, and you waste a lot of time simply to figure out what your program is going to do, or to find out some specific component that you want to make change, but you get lost, okay, because there are hundreds or even thousands of components, and how can you find the one that you need? Okay, so you always need to make a very clear structure of your program. So in this case, maybe we can use the mesh as our input. Okay, so we can actually create a black point here using this mesh, right? So this mesh goes here and also here, right? So we use this to replace it. Okay. And this part is simply a process that we use to create the mesh that we want. Okay, and this graph is also not a part of it, so I would want to delete it. Okay, one thing you can do is to make it safer, so it will copy the whole thing. Make a copy of it. No, undo it, because I can no longer select them. Okay, copy the whole thing and then move it somewhere else. Okay, so make it very safe. So now we can work on this part without changing the original part. Okay, so this is the kind of input that we want, and we want to output 1, 2, 3 set of force objects. So these are the 3 outputs that we want. So here we have the output, here, here, here. Connect to it, and then remove the link. So now it is clearly cut, and this is the input. Okay, let me change the display, file display, to be default. Okay, actually sometimes we might need other output. See these strings. How about if we want to change somehow the behavior of this structure, we may need to specify different strings other than the default one. So first I will extract the parameter and then use it as an input so that I can change it afterwards. I extract it and I extract it. I will drag all the input to the left hand side and then use this input component to connect them. And also we need to add the proper name so that we can distinguish which is which. So this one is for the length, right? Double click length. Oh, sorry, length. Length strength for both the name and the nickname. And the second one, this one is for the boundary edge, right? Double click. Boundary edge strength. And finally, this one is the internal edge strength. It should say, sorry, edge angle. And this one should be boundary edge angle. Okay, so I think now it is fine. Then we select all of them. Sorry, this one is not needed. So make it very clear. And one more thing you can do is to add some description. So you have your scribble. Okay, for example, you say to simulate. How do you spell membrane? Okay, lamella. Okay. And also you can explain the input, output, whatever. Okay, if you make it very clear, then it helps you yourself and also for other people. Okay, to get it. Okay, then you can select everything, click the right mouse button, and then finally you define the property of it, and then you make simulate lamella. Okay, and you have description here, and then you can even create an icon so that you can see it. You can understand what is it with this icon. Okay, and you can put your name so that you are the author of it. Okay, so now you have it. Now I can here we have create this part, right? So now connect this mesh to this mesh, and it has default value. Oh, something is wrong. This should not be 1. This should be 10. What is wrong? The default value of this should be 10. Okay, let me unconnect it and then set it to be 10. Shouldn't be 1. Okay, and then connect it back again and then save it. Hopefully it will become 10 or still 1. Okay, anyway, let me put it 10 here. Okay, now we have 3 sets, right? And also it's better that if we rename them so we know which output is for which, and we can still select which part we want to add into the simulation. Okay. So we have this one, we need 2 more, this one, and this one. Okay, and let's see. We have to delete this one. Disappear? Where is it? Again, something is wrong. No? Okay, so yeah, the first one is a null. Why? Sorry. Should be like this. Sorry. Okay. Now it is correct, and I hope it works. Okay. Maybe you can just try one thing. Let me find the control point of this rectangle. Curve control point of this rectangle, and get 2 points of it. Merge them into one list. And then set anchor. Okay, create one more slot. Okay, so these are the 2 points. Okay, let me change it to the 2 vertical oriented points instead of, okay, so let me say 1, because I want to hang this lamella. Here we have to match output. So you see now the right hand side of this is always hold it anchored, and then we can apply gravity to it. So for this mesh, let's check go mesh. I think there is no gravity. No gravity. Okay, so we find out all the vertices. Go to mesh, deconstruct mesh. My machine is getting slow, so I would turn it off. Create the mesh. So for all vertices, I'm going to apply a load to it. Here, this one, Kangaroo, load. Okay, and the default is going upwards, extra parameter, and I use vector, and then I reverse the direction of it. So the gravity goes down instead of goes up. Okay, and then maybe I have to make a little weight. We add one more slot and then add this gravity to it. Maybe I need more gravity. Okay, this is not so nice. Okay, because I'm not simulating a piece of cloth, so it doesn't look like a flag, but it looks more like this kind of structure. I mean, it's not a piece of cloth. If I simulate a piece of cloth, then it should fall down and with like softer. Okay, but right now I'm trying to simulate this lamina structure. Okay, so this is okay, but maybe we can try to adjust. We can try to adjust the strength of it. I'm misoriented. Okay, yeah. Maybe if I reduce the force, where is it? Here. The boundary edge angle forces, okay? Right now they are 1 and 1. I set them both 0.1. Ugly. Not so nice, right? It's too heavy. Make it less heavier. And okay, I just want to play around it. We add wind to it. Ghost mesh, here wind. And then we add a mesh to it. And for the wind, we need we need a vector. So we have vector blowing, how about the y-axis? Okay. And we can even try to rotate the direction of the wind. Should be like this, I think. We can rotate this vector, so transform, rotate, and then we can control the direction of the wind, so by minus pi dot dot 0.0 pi. Oh, sorry. Why is that? Minus pi. Yeah. Okay. Now we select this one, reset it, and now we can control the direction of the wind. Why? Why is that? It is not listening to me.
It linked to the load at the wing.
Okay, sorry. I rotate. Sorry, it should be this one, right?
I think it's because you didn't fix this point.
No.
So it's just falling.
Yeah. Should be this one. Okay. Hopefully it works. Now we are looking at the top view. Yes. Okay, so